On July 29, 1967, a single misfire on the flight deck of the USS Forrestal killed 134 American sailors in one of the worst naval disasters since World War II. Jet fuel erupted across the deck, and the Navy's existing firefighting tools could barely contain it. That catastrophe forced the military to adopt a revolutionary new technology, a foam that worked by drastically reducing the surface tension of water so it could smother burning fuel. Surface tension. Remember those two words, because that same scientific principle, the invisible force that holds liquid molecules together, is at the heart of one of the most persistent automotive myths on the internet. Here is the claim: a $2 bottle of acetone from your local hardware store poured into your gas tank in tiny amounts can permanently double your fuel mileage. And the most explosive part of the legend: both the US Air Force and Shell Petroleum supposedly proved this worked back in 1966, then buried the research to protect the oil industry's profits. Today on Historia Prime, we are going to trace this myth from a self-published internet article to peer-reviewed university labs, from conspiracy theory chat rooms to the Mythbusters testing facility. We will separate the real science, and there is real science here, from the dangerous lie wrapped around it. And we will pull out lessons about chemistry, psychology, and critical thinking that you can use long after this video ends. Let's get into it. Every legend needs an origin story, and this one belongs to a man named LaPointe. Starting in the early 2000s, LaPointe published a series of articles on personal websites and fringe energy forums, arguing that the internal combustion engine was shockingly wasteful. His core argument was straightforward: a large portion of the gasoline you pay for never actually burns. It exits your tailpipe as unburnt hydrocarbons. Wasted money, wasted energy. His proposed solution: acetone, the same volatile clear liquid found in nail polish remover and hardware store paint thinner. LaPointe was not a university researcher or a credentialed engineer. He was a self-taught enthusiast who claimed 50 years of independent fuel testing, but never published in any peer-reviewed journal and never submitted his data to independent verification. According to the LaPointe protocol, adding between 1 and 3 ounces of pure acetone per 10 gallons of gasoline could yield a permanent mileage gain of 15 to 35%. In some of his more dramatic claims, the gains were even higher. He created graphs he labeled the A, B, C, and D curves, showing how different vehicles responded to his acetone treatment. The internet ran with it. Forum posts exploded across automotive communities. People claimed smoother idle, cleaner exhaust, hundreds of dollars saved per year. The appeal was irresistible, a pocket change fix to a problem that costs the average American family over $3,000 a year at the pump. But the real engine behind the myth was not the chemistry. It was the conspiracy. LaPointe and his followers claimed that in 1966, both Shell Petroleum and the US Air Force independently discovered that acetone was a miracle fuel additive, and deliberately classified the findings to protect global oil profits. It was a perfect internet story, a cheap, simple solution that they do not want you to know about. So, is there any real science here? Actually, yes, and that is what makes this myth so dangerous. To understand why the acetone myth refuses to die, you need to understand one concept: surface tension. And the easiest way to picture it is this. Think about a drop of water sitting on a freshly waxed car hood. It beads up into a tight sphere instead of spreading flat. That is surface tension at work. It is the invisible elastic skin that forms on the surface of any liquid because the molecules pull inward on each other. Gasoline does the same thing inside your engine. When your fuel injector sprays gasoline into the combustion chamber, it does not instantly transform into a perfect, evenly distributed gas. The fuel molecules cling to each other. They form microscopic liquid droplets, tiny clusters where only the molecules on the outer surface of each droplet are fully exposed to oxygen. Here is the problem. For fuel to burn completely, it must be fully vaporized. But because of surface tension, the inside of those little clusters is essentially starved of oxygen. Those trapped molecules never combust properly. They get swept out the exhaust valve as wasted chemical energy, money you already paid for at the pump. This is where acetone enters the picture, and where the science is actually legitimate. Acetone is a polar ketone, and when you introduce even a small fraction of it into non-polar hydrocarbon fuel like gasoline, it disrupts those molecular bonds. It lowers the surface tension of the fuel. Published academic research confirms this. Adding a small percentage of acetone to gasoline measurably reduces surface tension, which means the fuel breaks into finer droplets. Engineers call this secondary atomization. Finer droplets mean more surface area. More surface area means better contact with oxygen. Better contact with oxygen means more complete combustion. So the backyard mechanics were onto something real. The underlying physics is sound. But sound physics and a working fuel additive are two very different things. And this is where the story gets complicated. What the university labs actually found. Here is where it matters to look at actual controlled experiments instead of internet forum posts. In 2016, researcher Ashraf El-Fasakani published what appears to be the first peer-reviewed study specifically testing acetone gasoline blends in a spark ignition engine. He tested a 3% acetone blend and a 10% acetone blend on a single-cylinder, 4-stroke engine under laboratory conditions. The results were real but modest. The 3% blend showed a brake power increase of about 1.3%. At 10% acetone, brake power improved by about 5.2%, and brake thermal efficiency, the measure of how effectively an engine converts fuel energy into mechanical work, improved by roughly 12%. Carbon monoxide emissions dropped significantly. Unburnt hydrocarbons fell by about half. A later 2023 study published in ACS Omega by Usman and colleagues confirmed similar numbers. The 10% acetone blend showed about 12% better thermal efficiency and nearly 7% lower fuel consumption compared to straight gasoline. But that same study revealed something the acetone evangelists never mention. The blended fuel caused measurably faster degradation of engine lubricating oil. Metallic wear particles increased. The oil broke down faster. Now, here is the critical context that separates laboratory data from the internet fantasy. These studies tested blends of 3 to 10% acetone by volume. LaPointe's protocol calls for roughly 0.03%, approximately 1/300th the concentration used in the studies that showed benefits. At the concentrations LaPointe recommends, the thermodynamic effect on combustion is essentially negligible, and the internet claims of doubling fuel mileage. No controlled study has ever come within a mile of that number. The best peer-reviewed result is a 12% improvement in thermal efficiency, at acetone concentrations far too high to be safe for a standard fuel system. So the real scientific picture is this. Acetone can measurably improve combustion, but only at concentrations that introduce a completely different set of problems. The 1966 conspiracy. What actually happened? Now let us address the heart of the conspiracy, the claim that Shell and the US Air Force proved acetone doubled mileage in 1966 and buried it. When you actually look at what happened in 1966 through documented historical records, you find three completely separate events that have nothing to do with each other. First, Shell. In 1966, the Shell International Petroleum Company published the 5th edition of the Petroleum Handbook. This was a technical reference manual covering the oil industry's operations. Sections on fuel additives discussed the use of chemical dyes to help consumers distinguish between different fuel grades, kerosene versus gasoline, for example. Shell was working on fuel detergents and standardization. There is no classified acetone fuel efficiency section. There never was. Second, the military. In 1966, the US Navy, working with 3M Corporation, patented aqueous film-forming foam, AFFF. This was a firefighting breakthrough that used synthetic fluorochemicals to drastically reduce the surface tension of water, allowing it to spread a thin, smothering film over burning jet fuel. This is the surface tension research that conspiracy theorists love to point to. But it had nothing to do with fuel economy. It was about putting out fires, and it was deployed with life-saving urgency after the USS Forrestal disaster the following year. Third, the Air Force was indeed studying acetone in fuel tanks at Wright-Patterson Air Force Base around this period, but in the context of worker safety. They were measuring how acetone vapors broke through the respirator cartridges worn by mechanics who had to climb inside empty aircraft fuel tanks to clean them. It was an occupational health study. Over the decades, these three unrelated historical facts, Shell's 1966 Additive Handbook, the Navy's Surface Tension Firefighting Foam Patent, and the Air Force's acetone vapor safety research, were stitched together into a conspiracy narrative. Someone noticed the words 1966, Shell, Air Force, surface tension, and acetone appearing in historical records and assembled a story of corporate suppression. There was no cover-up. But if the science is partially real, why does every automaker on Earth tell you not to put acetone in your gas tank? The Trojan horse in your fuel lines. This is the part that could save you thousands of dollars and potentially prevent a catastrophic engine fire. Acetone is one of the most aggressive organic solvents in common use. It dissolves things. That is literally its job in every application where you encounter it. Stripping nail polish, thinning paint, cleaning industrial equipment. Your car's fuel system is built from a carefully engineered combination of metals, plastics, and synthetic rubbers. Since the beginning of modern automotive manufacturing, the industry standard material for fuel hoses, O-rings, and seals has been nitrile rubber, also known as Buna N. Nitrile is excellent at resisting petroleum-based fuels like gasoline and diesel, but it has a fundamental vulnerability. It breaks down when exposed to polar solvents, ketones specifically, and acetone is a ketone. When acetone contacts nitrile rubber, even in small concentrations, the polar molecules penetrate the polymer structure of the rubber. The material swells, softens, becomes spongy, and eventually loses its structural integrity. Proponents like LaPointe argued that at his recommended ultra-low dilutions, the acetone would be too dilute to cause damage. But material science studies on long-term chemical exposure tell a different story. Cumulative damage from polar solvents is irreversible. It compounds over time. Think of it like sun damage on skin. You might not see the effect of a single afternoon in the sun, but years of exposure cause permanent changes. In older vehicles with mechanical fuel pumps and carburetor floats made from certain plastics, concentrated acetone can literally dissolve components. In modern vehicles, the real danger is more insidious. Slow degradation of fuel injector seals and high-pressure fuel rail O-rings. If an O-ring on a modern direct-injection fuel rail fails because it has become spongy from months of acetone exposure, you do not just lose gas mileage. You spray highly pressurized, atomized gasoline onto a 400-degree exhaust manifold. The result is an engine fire. There is a chemical-resistant alternative rubber called Viton that handles acetone without breaking down. But re-engineering the entire global fuel infrastructure, every refinery gasket, every gas station pump hose, every O-ring in every vehicle on Earth, to use Viton instead of nitrile is an economic impossibility for a single-digit percentage improvement in thermal efficiency. The auto industry did not avoid acetone to protect oil company profits. They avoided it because the fuel system materials were never designed for it, and the cost of redesigning everything would dwarf any savings at the pump. The but dyno. Why people swear it works. So if the lab data shows modest gains at dangerously high concentrations, and the recommended low dose is essentially a rounding error thermodynamically, why do thousands of people on internet forums swear acetone doubled their gas mileage? The answer is one of the most well-documented phenomena in psychology, the observer expectancy effect. In the car world, they have a perfect name for it, the but dyno. It is the subjective, unscientific feeling that your car is performing better because you changed something and you want it to work. Here is what actually happens. A driver pours their $2 magic potion into the tank. They subconsciously want results, so without realizing it, they change their driving behavior. They accelerate a little more gently from stoplights. They coast longer before braking. They avoid jackrabbit starts. These subtle behavioral shifts alone can easily produce a 15 to 20% improvement in fuel economy, entirely independent of any chemical in the tank. There is a second effect at work too. Acetone is a solvent. When you pour it into an older, poorly maintained engine, it can dissolve years of accumulated carbon deposits and varnish from intake valves and fuel injectors. The engine gets a chemical cleaning. The driver experiences a return to something close to original factory performance and mistakes that restoration of lost efficiency for a miraculous new gain. The television show Mythbusters put this to the test in episode 53. They took both a carbureted vehicle and a modern fuel-injected car and ran them under rigorously controlled conditions on a dynamometer, eliminating human driving bias entirely. The results were definitive. In both vehicles, adding acetone slightly worsened fuel economy. The carbureted car dropped from 25 to 24 miles per gallon. The fuel-injected car dropped from 27 to 26. The myth was busted. But here is the thing worth remembering. The Mythbusters result does not mean the chemistry is fake. The surface tension reduction is real. The improved atomization is real. What is not real is the idea that a microscopic dose of acetone in a fuel system designed around nitrile rubber is a safe, practical, cost-effective way to improve your mileage. The myth survives because it wraps a grain of real science inside a package of wishful thinking. So what do you take away from the acetone story? Not just about cars, about how you evaluate any claim that promises a cheap, simple fix to an expensive, complex problem. First, the shortcut trap. Acetone in the gas tank is the automotive version of a miracle diet pill. The promise is the same, a small, cheap intervention that bypasses the hard work. But the actual path to better fuel economy is unglamorous and proven. Keep your tires inflated to the correct pressure, change your air filter on schedule, keep up with routine maintenance, and drive with a lighter foot. The most reliable way to save money at the pump has nothing to do with what you pour into the tank and everything to do with how you use the pedals. Second, know the materials you depend on. The downfall of acetone as a fuel additive was not the combustion physics. The physics checked out. The problem was material incompatibility, the fact that every rubber seal, hose, and gasket in your fuel system is made from a material that acetone slowly destroys. This principle applies far beyond cars. Whether you are choosing a water filter for emergency preparedness, selecting gear for extreme weather, or evaluating any product that contacts chemicals, the question is not just, does the active ingredient work? It is, what does the active ingredient do to everything it touches? Third, learn to spot a stitched-together conspiracy. The 1966 myth was built by connecting three real but unrelated historical facts: a Shell reference handbook, a Navy firefighting foam patent, and a military acetone vapor safety study. Someone saw overlapping keywords, and assembled a narrative of suppression. This technique, cherry-picking real data points and arranging them into a false pattern, is one of the oldest tools in the misinformation playbook. The antidote is always the same. Trace each claim back to its primary source and ask whether the original context supports the conclusion being drawn from it. The acetone fuel myth is a case study in how a genuine scientific principle, surface tension reduction, can be hijacked by psychology, historical misunderstanding, and the universal human hope for a shortcut. We started this story on the burning deck of the USS Forrestal, where the military's real research into surface tension led to a firefighting foam that saved countless lives. Somewhere along the way, that legitimate science got twisted into a conspiracy about hidden fuel economy secrets. The truth is less dramatic, but far more useful. Acetone genuinely improves fuel atomization in laboratory conditions, but it does so at concentrations that slowly eat through the rubber components your car depends on. And at the doses internet forums recommend, it does essentially nothing, except give you a placebo and a slowly deteriorating fuel system. The greatest trick this myth ever pulled was not exposing a buried secret from big oil. It was convincing people that a $2 bottle from the hardware store could replace engineering, maintenance, and common sense. Thank you for exploring history and science with us here at Historia Prime. If this one gave you something to think about, hit subscribe and tell us in the comments what is the most persistent, too good to be true hack you have ever encountered. We want to hear your stories. Stay curious, stay skeptical. We will see you in the next one.